Right, so moving on to question 9. Okay, and it's asking us to calculate the refractive index for the glass. And we need to use the diagram, so that means that we're going to have to take some measurements from it, right? Okay, so how do we do this? First thing, whenever you come across any sort of ray diagram, is to draw the normal. And as we talked about earlier, it's conventional to draw this as a dotted line. It has to go through the point where the ray hits the glass block, okay, and you can check that that angle between there and there must be 90 degrees, right? So where do we draw the normal? Always exactly the same point. It's where the ray hits the glass block, okay, and it's at 90 degrees to the surface, okay? So now that we've got that in place, we can start to label this up and see what we've got. This is between the incident ray and the normal, so that's the angle of incidence, and this is between the refracted ray and the normal, so that's the angle of refraction. All right, now you need to measure those two things carefully with a protractor. Yes, that's right, you do need a protractor for a physics exam, okay, and if you measure it carefully, that's 60 degrees and this is 31 degrees, and you should be able to measure to a precision of 1 plus or minus 1 degree for those. All right, so now we need to know the relationship between those two things. It's topic 3, which is the waves topic. Right, and there it is, angle of incidence, angle of refraction. Great, we've got the formula. So n equals sine I over sine r, that's my formula step. So now I can do the substitution. Okay, sine 60 divided by sine 30. All right, and then that gets me my answer, which is 1.68147 blah 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 blah. Okay, and again we've got to think about what's a reasonable number of significant figures to give our answer to. Okay, 1.68 or 1.7 would seem a reasonable number of significant figures there because of the input data. Just one thing, if you ever do a calculation and you get less than 1 for the refractive index, stop and do it again because you've definitely got it wrong. All the refractive indices, okay, are typically between 1, which is the refractive index of a vacuum, okay, very similar to 1 for air, okay, and up to a maximum of for normal substances like diamond is one of the highest, which is 2.4. So if you're getting an answer that's in that range 1 to 2.4, you know you're in the right ballpark. Okay, if it's outside of that range, then you made a mistake. Go back and have another look at it. All right, so how does the student improve her investigation to obtain more reliable value of the refractive index? Okay, well, you might remember doing this practical. Okay, if you look at the formula, okay, then in physics we're usually trying to plot a graph, right? And if we plotted a graph of sine I on the y-axis against sine r on the x-axis, okay, then the gradient of this graph would actually be n, the refractive index. M stands for gradient, right, in maths. Yeah, okay. You can convince yourself of that by comparing this equation to the formula y equals mx plus c for the gradient of a straight line, right? So if that's the point that we're trying to get to, then we need to work backwards from that, right? So to be able to plot this graph, we're going to need to get some values of sine I and sine r, okay, which means that we're going to have to get ourselves a data table, okay, and we're going to have to measure some different values of I, some different values of r, and calculate sine I and sine r to be able to plot that graph, okay? So an idea of varying the angle of incidence and then plotting a graph of sine I against sine r, and then the gradient of that graph being the refractive index. That's kind of the gold standard that you can have there. And of course, within this, you could take multiple values of each, multiple readings at each of those values. So if you were doing it at 10 and 20 and 30 degrees, okay, then you could take multiple repeats of each of those values. You've got to be careful with that though, because in the mark scheme, it says under the notes for the examiner, it says ignore bold, repeat and average. So if all you've basically said in your answer is, oh, do a load of repeats and take the average, that's not going to be enough to get you any marks here. Okay, so we've got to be really quite specific about, if you're going to take averages, then you've got to do, let's say 3 different repeats at 10 degrees, okay, and then you're going to take the average of all of those repeats, okay. This way that I've just outlined though, to plot the graph and do it from the gradient of the graph, then that's the absolute gold standard for that experiment.